All right, we are group 158. I am Jacob, and this is Christian and Shareful. And we did our project on convolutional neural networks to classify emotions. So our motivation. So our motivation was to create a model that would be able to recognize human expression to better bridge the gap between machine and emotion. So we wanted to make this a convolutional neural network because we felt that it was the best for the images uh, that were the inputs and outputs of the data set, which I'll get to in just a second. So inputs and outputs. So the dataset consists of a 48 by 48 pixel grayscale image inputs. Uh, we have one hot encoding with seven different classes. We got angry, disgust, fear, happy, sad, surprise, and neutral. Below you can see the link to our dataset and you can see the image of the dataset. One thing that's important to note is that our dataset was the severe limiting factor. And when we started this project, we had access to a different dataset. It was an easier to use one. Um, it had 96 by 96 color images. And this new dataset, the training set had a very vast uh, imbalance we discovered with disgust. It has less than 300 entries, and when you split data into training and validation, it was even less. So something to note is that originally when we were training, we didn't get any, uh, it wasn't recognizing disgust for the first few training intervals. Um, there's also these strange images that aren't even human. We got drawings, images with text. Some of them don't even have faces in them. And then we have artificially generated AI. Not only are they not human, they also are sometimes incorrect. Like this face right here is under the surprise class. This is likely due to this dataset being from an auto scraper or auto image getter, um, leading to it being inaccurate, which was a severe limiting factor in our accuracy. So in order to help compensate for some of this, we did some data augmentation. We did an 80-20 split on training and validation. We also did some transforms to prevent memorization. We did some resizing, some flipping, some color jitter, just to get that perfect balance. This also is a per class basis, so every class will have a minimum of this amount for each set. So,
So the data we're working with is image data. We're trying to classify it and label it. The easiest architecture for this is probably convolutional neural network. A particular CNN needs 6 convolutional layers, each identical padding, kernel size of 3 with row activations, with 2 fully connected layers, also with row activations. We use an atom optimizer with cross-entropy losses, our loss evaluation function. Uh, as you can see, we have dropout in between the convolutional layers and dropout in between the fully connected layers in an effort to curb the overfitting we were seeing basically at all stages of this model, as well as a weight decay in the atom optimizer itself. Next. Again, you can see here 10 randomly selected images from the test set that were run through the model, and you can see above it the true label and the predicted label. You can see what Jacob was talking about earlier, where some of the data is very poor. If you look closely, I'm sure you can see here some mislabeled emotions from the actual data set, along with pictures with text on them. You can see one was Shutterstock. You can see pictures that are not effaced at all. They're like waveforms or text of some sort. Next. Same thing here, just a lot of poor quality images. Next. Regarding our actual results, we ended up with a balance actually about 62% on the test set. The biggest hurdles for this were the anger and surprise classes. You can see that uh, things are regularly being mislabeled as anger or as surprise, and in particular, surprise itself is regularly labeled as another emotion entirely. And that's causing our XG to go down pretty hard. Next. And here are references, the Kaggle data set, a few examples of applications of emotion recognition I mentioned earlier. For example, detecting deception through facial cues, stuff like that.
Here are some extra predictions that I just wanted to add in here to show you that its basic functionality. I used some real images and it did get it correct. Even for a weaker class like anger, it got it correct. And then uh, here are some of the examples of it working with uh, images in the training data set. Now, this it was predicted to be neutral, but it doesn't have a face. So just wanted to point that out there that there are some inaccuracies still. But in the future, to better improve it, we could scrape the data set for these images and uh, auto remove them and clean it up and just get better data. The previous data set probably had better data, but there's no way to prove that because it got taken down. This has been our presentation. Thank you so much for watching.